everyone, in this video we are going to determine the area of a triangle when the height is not given but the sides are. So in the previous video we already had solved the area of a triangle when the height is given and the base is given, but in this problem right here there's no height given to us, but instead the three side lengths are given. If this is the case here, when there's no height, we're going to use the Heron's formula. So the Heron's formula is this one right here. Area is equal to this equation under the square root, where our S here stands for the semi-perimeter. And the formula for the semi-perimeter is we add all the three sides, A plus B plus C, divided by 2. So it's like half of the perimeter. Now let's have an example to better see how this equation works. So let's take this example right here. So again, I will put the formula that we got from the first slide. So this was the formula that we got. So we are supposed to find the area. So we label, again, there's no height for this. We don't know what the height is, but we are given the three sides. So we label the sides first, A, B, and C, so we can plug those numbers into the equation. So let's take this is our A, this is our B, and this is our C. So then the first step that we need to do is to find for the semi-perimeter. To do that, we are going to use this equation right here. So that would be S, or the semi-perimeter, is equal to A plus B plus C. So that would be 7 centimeters plus 8 centimeters plus 9 centimeters divided by 2. So then if we add these three together, that would equal to 24 centimeters divided by 2 is 12 centimeters. So our S is 12 centimeters, and this number will be plugged into all of the S's into this area formula. So then we are ready to solve for the area. So area is equal to the square root of, we plug those values in. We start with the S, which is 12 centimeters. So that's 12 centimeters times the S again is 12 centimeters minus our A is 7 centimeters. And then times, then we have again the S is 12 centimeters minus the B is 8 centimeters, and then times, we also have another S, which is 12 centimeters minus the C, which is 9 centimeters. So then from here, we simplify this. This would come out to be the square root of, we have a 12 centimeters times 12 minus 7 is 5 centimeters. And then we have 12 minus 8 is 4 centimeters. And then 12 minus 9 is 3 centimeters. Now, if we multiply 12 times 5 times 4 times 3, that would come out 720 centimeters to the fourth power. So you have centimeter times centimeters times centimeters times centimeters is centimeters to the fourth power. Now, we can break this down into a square root of 720. So we will see what's going to be the unit for this. So I'm breaking them down. So that would be square root of 720. And then that's centimeters to the fourth power. Now let us see what's going on with this centimeter to the fourth power. How can we simplify this? We remember that we can change radical to its rational exponent form by rewriting it as centimeters to the power 1/2 to the fourth power. So this, again, there's another video on how we can change radical to its rational exponent form. I will put the link of that video in the description box below. So from here, we can come up with, there's this 4 here has an invisible denominator of 1. So then we can go ahead and say this is centimeters to the power. 4 times 1 is 4. And then 2 times 1 is 2. So then we are able to come up with centimeters squared, which is a unit of area. So if we get the square root of 720, that would equal to 26 83. And then the final unit here is centimeters squared. So that is how we find the area using Heron's formula. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!